So let's go over these nomenclature questions now. One of the most important things to keep in mind with a lot of these nomenclature questions, especially as we get further and further on in this course, is all of the things that we previously learned for nomenclature still matter. And one of the big things I see students forgetting is, a couple chapters ago we learned R&S nomenclature for stereocenters. Well, we're out of that chapter, but there are still stereocenters in this molecule. So you still have to apply that. All right, so first question, what's our longest chain? And we can see our longest chain comes here. Now, which direction do we need to number it? This one's actually pretty straightforward, because one end of the chain starts with an alkene, the other end doesn't. And remember, it's the alkenes, the pi bonds, that take priority over any other functional group or substituent that might be present. So we have a 9-carbon chain, so we know we're dealing here with nonane. And now, as we have in the past for more complicated examples, and I think often benefits us, I'm just going to start by making a list of what we need to do at each carbon. So carbon 1 has an alkene. Carbon 3 has a cyclopropane ring, which is a substituent we just call cyclopropyl. Carbon 3 also has an alkene. 4 has an ethyl. 5 has a methyl. And 5 is also chiral, so we know we need to do R or S at that position. Carbon 6 has another alkene. In addition, 6 has an isopropyl. Carbon 7 has a methyl. 8 has a bromine. And 8 is also chiral. And 9 has nothing. So now I can use this to sort of make this more organized as we go. So I'm going to start by doing the substituents. We'll worry about the RS and the EZ at the end. All right, what comes first alphabetically? That would be the bromine. So we have 8 bromo. And then I'm just going to cross each one of these off as we use them so that we know that. Next is cyclopropyl. The term cyclo is not a numerical prefix. It's part of the name of what that group is. So that gets alphabetized under C. Then we have 4-ethyl. 6 isopropyl. And 5,7 dimethyl. So that's completed our substituents. What's our root name? Well, we already said it was nonane, but we have 3 alkenes in it, so we have to account for those as well. So this becomes nona. The alkenes are at 1, 3, and 6, so nona 1, 3, 6 triene. So the final piece that we need here are descriptions for stereochemistry. And we need those, both the E and Z, as well as the R and S. So which positions need those labels? Well, our first alkene, the one at carbon 1, has the same substituent, a hydrogen, as its substituent on the first carbon. So 1 does not need a prefix for E and Z, but 3 will. We already said 5 and 8 were chiral, and 6 will also need an EZ descriptor. Alright, so I'm going to erase what's on that structure just so we can see it. So we can see it better. And then I'll erase as we do each spot. So if we start with the alkene here at carbon 3, that's the one that I'm going to highlight here in green. What's higher priority on each side? Let's start on the left side. So we have a carbon versus a carbon. So now we have to see what that carbon is attached to. This carbon is attached to a methyl, while this carbon here is attached to 2 other carbons. So we have higher priority, lower priority. Now the other one's a little bit harder. And that's because we start here with a carbon that's attached to 2 carbons, which is the same way we count the alkene. So we have to go to the next carbon. Now that's a carbon that's attached to another carbon, and it's actually the same here. But the difference is, because we can keep going around the ring, we get to a 3rd carbon here. And with the alkene, we've only got 2. So that means the cyclopropane ring is higher priority than the alkene. Our higher priority groups are on the same side, so this is 3Z. Alright, let's erase that so we can do our next spot. Now let's look at the other alkene. On the left side we have a methyl here versus a carbon attached to a bunch of other stuff. So that's going to be higher priority over the methyl. On the other side we have a carbon bonded to 2 carbons versus a carbon bonded to 2 carbons. So we have to go now past that carbon. One of them is a methyl in each case, but the other one is a methyl versus the rest of this molecule. So higher priority, lower priority. Higher priorities are on the same side, so 6 is also Z. Right, now we have the 2 stereocenters to worry about. And we're going to start with this center right here. So the first thing that makes this one a little bit easier is the 4th substituent, the hydrogen, which is the low priority substituent, is already pointed back. Now, each of the other 3 substituents are carbons. So the methyl is going to be the lowest priority of those 3. Then here we have a carbon with an alkene and another group. That's the same so far. So again, it becomes a matter of which one, once we go further, is going to be higher priority. And so if we extend past the alkene, we get a carbon bonded to 2 carbons. Same thing on this side. When we go one step further though, we get the bromine, which means that's higher priority, higher atomic number than any of the carbons on this side. And we go counterclockwise, or 5s. One final stereocenter, that being the one with the bromine. This one's actually a lot easier. Bromine is highest priority. Here's a carbon bonded to 2 carbons versus a methyl, 2, 3. our arrow is clockwise, which would be R, but because our lowest priority substituent, the hydrogen, is pointing forward, we have to take the opposite, and we get S. So 3Z, 5S, 6Z, 8S, 8 bromo, 3 cyclopropyl, 4 ethyl, 6 isopropyl, 5, 7 dimethyl, nona 1, 3, 6 triene. Very involved in a name like this, but really it's just a matter of going step by step, being careful as to how you go through this, and make sure you don't leave anything out. And so that's why I find that, when you've been doing this for years and years, you might not need to make a list like this. At that point, you may find that you can, in fact, juggle all of that information in your head. But for right now, when you've got a complicated molecule, you will find that it'll make life a lot easier to write everything out, make a nice organized list, and work from there. All right, let's go on to number 2 then. So a lot of the same types of things going on in number 2. I think we can see fairly readily that our longest chain goes straight down the middle. And again, because we have an alkene at one end, we know that's the end where we're going to have to number it, starting from. So again, we have a 9-carbon chain. Again, I'm going to do the same thing, and I'm just going to label what we have, or make a list. So carbon 1 has an alkene, 2 has a methyl, 3 has a methyl, 4 has a methyl, 3 also has an alkene, carbon 5 has a cyclopentane ring as a substituent, so cyclopentyl. 5 also has an alkene. Nothing at 6. 7 has a chlorine. 7 also has a methyl. And 7 is chiral. Carbon 8 has an iodine. And carbon 8 has a methyl. Is carbon 8 chiral? The answer is no, because 2 of our substituents here are methyl groups. Alright, so let's do our stereochemistry first. The stereochemistry we're going to need to determine is EZ at 3, E or Z at 5, and R or S at 7. So the first alkene, this one, carbon 1, the left side of that alkene has 2 hydrogens. So since those substituents are identical, E and Z don't apply. Our next alkene has a methyl on one side versus a carbon group on the other side. And the other side's actually very similar. The methyl is going to be lower priority than the large carbon group. So our highest priority groups are on opposite sides, so that makes this 3E. Alright, our second alkene that needs the E or Z label, the one at carbon 5, the right side's pretty easy. One of the substituents is a hydrogen, which is always lower priority than anything. On the other side, though, we have a carbon here bonded to 2 carbons, carbon bonded to 2 carbons. But when we get out to this next spot where we have a carbon bonded to, that's only bonded to carbons versus the next carbon in the cyclopentane ring has some hydrogens, we know that this has to be higher priority. Our higher priority groups are on opposite sides, so we have 5E. And finally, our stereocenter. Our stereocenter here has something slightly unusual. That's the fact that a methyl is actually our lowest priority. So we're very used to seeing stereocenters where hydrogen is the lowest priority, but here it's the methyl. Chlorine is highest priority, and then we have two carbon groups here. The one on the left is a carbon bonded, double bonded to a carbon, but over here we have a carbon bonded to an iodine, and so that iodine is going to be higher priority than the remaining carbons. Our lowest priority is already pointed back, so we don't have to switch anything. Our arrow goes clockwise, and so we know that this is S. So we've taken care of that. So now it's just a matter of putting our substituents in alphabetical order. That starts with chlorine, 7-chloro. Then we have 5-cyclopentyl. Then iodine, 8-iodo. And then we have all these methyl groups. So there's 5 of them. So that's pentamethyl. And finally, nona 1,3,5-triene. Alright, so I'm going to do the last 3 nomenclature questions in a separate video. This video is already up to 17 minutes, and I prefer not to run this up over 30 minutes.